Flack math! Give me some math and I'll give you some flack. Flack math!
All right, just 2 lessons. Don't forget, if you do your practice tests by Thursday, I'll give you 5 points extra credit on your actual test. Make sure you upload the practice test in the practice test square and the test in the test square. I'm not going to mention any names. And if you haven't done it already in previous tests, make sure you go back and do that. I'm not going to mention any names. But yeah, 87. Let's do it. We're going to multiply algebraic terms. So this is where algebra gets kind of interesting.
Boring?
No, never boring. So multiply algebraic terms. Remember, a term in algebra are things that are added or subtracted, right? So for example, this is a term. So if I added it to like 5x cubed y squared, so this is 2 terms, right? And you can't add these together because they're not like terms. So what we're going to do is we're going to multiply terms together. Remember when you 1/3 plus 2/5. What's 1/3 plus 2/5? Don't say 3/8. Don't say 3/8. Don't say 3/8. You said 3/8. Okay, right? That's what you do. You say 3/8 after a long summer and you haven't mathed in a bit, and you're lazy and you're 3/8. Oh wait, you need that stupid common denominator, whatever. So no, you have to find a common denominator. But when you multiply, well, that you can go straight across, right? So that's just 2/15, right? Well, now you're realizing that addition and subtraction used to be the easier thing in math, and multiplication and division were a little bit more complex, right? Well, now we're reversing it. Multiplication and division are going to be easier than adding and subtracting, because adding and subtracting, you have to be picky. You have to find what they have in common. You can only add like terms or like denominators. But with multiplication, you just multiply away. You just squish it all together. And that's what it feels like when you're multiplying in algebra. You're squishing it all together. Here's what I mean by that. So if I did this, let's start with an easier one. Let's just start with 3x times 2x.
What's x?
Anybody know what that is right now? You know what it is?
6x.
Okay, good guess, but no. And I haven't taught you yet, so good job for being brave and guessing. Any other guesses? Yes.
6x squared.
6x squared. Okay, here's what's happening. Remember that property in multiplication that says it doesn't matter what order you multiply in? It doesn't matter. So you could just multiply 3 times 2 times x times x. Everyone okay with that?
Yeah.
What's 3 times 2? And what's x times x? X squared. That's it.
I was right.
You were right. Okay. So now it's hard because when you add 3x plus 2x, it'd just be 5x. You don't touch the variable. You just add the 3 and the 2. But when you multiply, you squish it all together. See how I just squished it all together? 3 times 2 times x times x. You squish them all together. All right, what about this? What about this? Negative 2x times negative 3y. What is that going to be? Hunter?
6xy.
6xy. You just squish it all together. The only thing that you can actually multiply is the negative 2 times negative 3, right? Which is positive 6, because negative times negative is positive. X times y is just x times y. You just squish it together. Okay? Let's try something else. See if you can do this. Don't say it out loud.
Do we get free problems at that point if we do it?
No, but I'll give you a Flack attack if you do it. You can do that. Squish it all together. What do you get?
can't do it while I'm trying. This is it.
All right, hide it. Don't tell anybody.
Okay. Does that have to be on paper?
No.
I just did it on my paper because my brain can't say the words that were in my brain.
And she did it. She was the first one to get it, and she did it on paper. So paper doesn't necessarily slow you down.
But paper.
Get it?
I know.
Very close. The 20, that first part's right. What'd you get? Yep.
So
Good job.
I think I might have it. My brain did this.
All right, 1 second.
Whoa. Just over that.
Yep. That Y's right. Yeah. Fix the X. Nope. So obviously that first part's wrong. Okay. Okay, what about the X?
Wait. Hold on.
Elijah, you got something? No. How many X's have you multiplied?
I think I know.
How many X's are you squishing together?
24. I don't know what I'm doing. I am.
Closer.
My brain's just not working. Yeah.
Are you just trying to look busy right now?
I'm trying to.
Anybody else?
That was fun. I can't.
Maybe that would be the case if you couldn't read my handwriting. If you thought one of the X's was a Y, that would be right. Okay. Let's do it. So let's do the numbers first. First of all, I see this as 3 different parts. First of all, let's determine whether it's positive or negative. Is it positive or negative? Answer, Adeline.
Positive.
Why?
Because if you multiply like symbols, it always ends up
Yep,
with
so this is positive, and then times another positive stays positive. And another way you can think about it is there's an even amount of negatives being multiplied. Okay, did you get an answer? Okay, so then the next part is I'm just multiplying the numbers. Everyone did that right, except Grady the first time, but he just had a brain fart. Okay, what's 6 times 4? 24, right? Let's squish all the X's together. Marin? X squared times X times X. How many X's are being multiplied?
3.
XX, X, X. There you go. X to the 4th, and then Y to the just Y times Y. What's Y times Y?
I had it so close.
Yep, you had X to the 4th, and then you just gave up. You fell off.
I fell off. I
Yeah.
did Y squared.
Okay, so see how you're really just looking at 2 things. I mean, the positive or negative, just get that out of the way so it's not confusing you. Okay, just figure out if it's positive or negative, and then you can ignore the negative and positive signs, okay? And then just multiply the numbers. 3 times 2 times 4, 24. Squish all the X's together. This is XX, XX. 4X is being multiplied. Y, Y, Y. Okay, Y is just Y squared. Does that make sense? All right. All right, redemption. Here we go. Example 2.
Now they're A's and B's.
All right. So if you have it and you don't want to write it down, that's okay. Just hold on to it, and you can tell me at the last minute. Yep. Good job. Oh wait. Yep.
That's it.
So that is not only wrong, but it's
Oh,
the
wait.
opposite of right. There you go. And then fix B. The
Oh.
exponent on B is not right.
So that's.
Okay, so fix A.
There we go.
Oh.
Yep, good job.
Wait, a negative times a positive is a negative, right?
Yeah.
Okay, good. Let's get. That's right, and then this is just negative. Right? Good job. There it is. You better not mess it up this time. So what about the A's? How many A's are being multiplied?
Oh, no, you have A squared.
Yep, that's it.
Fix my answer.
I'll fix my answer. That's right. Is that a 2 or a 3? Okay, good. You guys get it?
No.
Are you on handwriting?
Trying to figure out my handwriting? It's not that bad, is it? Come on.
It's better than my phone.
Okay, so what did we do first? We did a negative times a positive number, -6. Everyone get that far?
Yeah.
Okay, now this is just A. So A. 3 A's, A cubed. This is B. B to the 5th. Really what you're doing here, remember, you're just adding the exponents. When you don't see an exponent, it's just 1. 1 plus 2 is 3. 1 plus 1 plus 3 is 5. See what we did? Okay. You guys got this? This feel doable? All right. If you can read the handwriting. That's 87. Let's do 88, and then we'll be done.
All right.
All right, 88. We are converting an area, okay? So I'm going to ask you a question, and I'm betting that most of you will get it wrong. That sounds like a challenge.
Yeah.
Okay, converting an area.
Oh.
Well, don't feel bad because I already told you that most of you will get it wrong. So you technically you did what you were expected to do.
That sucks.
What is that? Nope. Well, we're converting to square inches, not. Okay. Yes. Nope. No. 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 Nope. Nope.
Oh, but it's huge. Oh.
Sometimes I just want to tell you get the right answer so you don't yell at me.
Yeah.
Oh, sorry. I thought you were raising your hand. Okay. Yeah. Do you know? Oh, you had me. It's 4 something, but it's not 42.
4 inches.
It's not a 2-digit number either.
The heck?
Okay. What is a square foot?
Square foot?
What is a square foot?
Foot's in weight 4.
Yeah, it's like a tile on in a bathroom, right? So here's a square foot.
Wow.
So each side is, I can't put my leg up that high, but this is 1 foot by 1 foot. Everyone agree that that's a square foot? How many square inches are in a square foot?
Oh, 140.
144. Look, this is 12 inches by 12 inches, right? We've got all these. We got a 12 by 12 like all these are square inches. There's 144 square inches in 1 foot. So how many square inches are in 3 of these?
144 times 3.
You know?
432.
432. Okay? Crazy, right? Everyone, like most of you said 36, which is what you were expected to say, right? Because there's 12 inches in a foot. But these are not inches, and these are not feet. Okay? Inches are 2-dimensional, completely different dimension. All right? Square feet and square inches are a whole new thing. Okay? So, yes, there are 12 inches in a foot, but there are 12 square inches in a square foot. So when you go to the next dimension, second dimension, you have to square the conversion factor. So do you understand what I mean by conversion factor? So in inches and feet, the conversion factor is 12. You either multiply by 12 or you divide by 12, right? That's the conversion factor. So in square inches and square feet, the conversion factor is not 12, it's 12 squared, which is 144. So the rest is the same. You either multiply or divide by 144, but not 12. All right, that seems confusing, but when you use unit multipliers, it's different. 3 feet squared. First step to unit multipliers is put it over 1. And then what's the next step? You have to multiply by a unit multiplier that will cross cancel the first label. Okay? So what cross cancels feet? Well, 12 inches over 1 foot. But see how this foot, this is not foot. This is foot. Right? Feet squared is feet times feet. This is feet. So this only cancels one of those. So what do you need to do? You need to cancel the other one. Multiply by another 12 inches over 1 foot. And that gets rid of the rest of the label. So when you multiply by one of these unit multipliers, it only gets rid of like half of that label. But this label's not feet, it's feet. So when you multiply by 12 inches over 1 foot, it only gets rid of one of the feet in feet. You got to get rid of the other feet in feet. So to do that, multiply by another unit multiplier. So what do you end up with? 3 times 144, which is 432. Inches, or square inches. Okay? So unit multipliers takes the brain out of it. You don't have to worry about, okay, how many square inches are in a square foot? Let's see, 12 times, 144. And then, all right, so 3 times 144. You don't have to do any of that. You don't have to think about it. Unit multipliers does the thinking for you. You just have to remember the main goal in unit multipliers is to cancel labels. You can deal with the numbers later. It'll tell you what to do with the numbers. You don't have to think about, okay, do I multiply or divide? So going from big to small, small to big, I'm confused. Okay, don't worry about that. Let's try an example. Ready? Let's try 10 yards. Well, let's do something else. Let's do something else. Let's do something else. 5 square yards equals how many square feet? So you can try to math this out and think about it, or you can use unit multipliers. And when you're converting an area, remember to get rid of 1 unit, you have to like do it twice. So how do you get rid of yard?
Oh.
So you can write it like that if you want. This is yard squared, or yard times itself. Now, how do you get rid of those yards? You just gave me a number. That's right. Okay. So now you did the math, though. Let's see if we can do this using unit multipliers. Not that those are different things, but how would you do this? How do you get rid of yard? How do you get rid of one of the yards? Hunter?
I have an answer.
Okay, how do you get rid of one of the yards in unit multipliers? What unit multiplier will cancel the yards? Do you know?
So then you're gonna do it 3 feet over.
Yep,
1
3
yard,
feet over 1 yard. That gets rid of one of them.
and do the 3 feet over 1 yard again.
Yes, do the 3 feet over 1 yard again. And that gets rid of the other yard.
And then
Right? And then you're left with 5 times 9 to get 45. So 45 square feet. The other way you could do it, guys, is right now it's pretty simple because if there's 3 feet in a yard, that means a square yard is going to be 3 feet by 3 feet, which is 9 square feet in 1 square yard. So 5 square yards is 5 times 9 square feet. Okay? All right, that's one way. So this is using 2 unit multipliers to get your answer. All right, there's other ways that we could use 2 unit multipliers. For example, look at this. 10 yards, just yards, not square yards, just yards, equals how many inches? Well, we could just do the math right now, or we could just use unit multipliers. We have to get from yards, which is like right here, 2 towns over. So how do you get from yards to feet? How do you get from yards to feet? What unit multiplier do you multiply by?
yard.
Grace told me last time, she said the same thing. What do? Grady?
Multiply by 3 feet over 1 yard.
3 feet over 1 yard will cancel that yard label, right? So now you're in feet town. Now you got to get from feet to inches. Oh, we know how to do that. How do you do that? What do you multiply by to get from feet to inches? 12 inches over 1 foot. So what are you multiplying by? 10 times 3 times 12, or 10 times 36 is 360 inches. And that's the only label you're left with. Everything else canceled all over 1. So just 360 inches. Okay. That's using unit multipliers. Now you could think about it logically. Well, I have to get from 10 yards to inches. All right, well, if there's 3 feet in a yard and there's 12 inches in a foot. So that means there's 36 inches in 1 yard. Think about a yardstick, 36 inches. So you could just multiply by 36 and be done. Okay, but this is a good way to practice on these easier ones, to practice using unit multipliers, because these are going to come in handy when you get to upper level math and upper level science. Okay. All right. Let's do 2 more and then we'll call it a day. Ready? 5 hours
Oh, yeah.
equals how many seconds?
How many
Well, you don't have to know how many seconds are in it. How many seconds are in an hour? Just go one step at a time. Where do you convert hours to?
2 minutes.
Okay, and then you know how to convert minutes to seconds. So do it.
I broke it.
This is a lot of seconds. I'm just saying. It's a lot of seconds. Do you know? Do you have an answer? 1,800 seconds? It's a lot of seconds. Are you sure?
I got 300.
I got 18 and then 3.
I don't think it's
I also-
18,000. That's even more seconds. 18,000 seconds. Anyone get anything different?
I got 300, but I don't think that.
300. Okay.
I got 1,800.
1,800. So I've gotten 1,800 and 18,000. Anybody else?
Right?
Okay. How confident are you guys? Do you want to bet? You want to bet a free problem set?
Actually, I'm changing mine. I figured mine. I
What
think it's 18.
18,000. So both of you think it's 18,000.
I'll go
All right.
1,800 then. They're doing 18,000. Let's do 1,800.
Okay.
See.
All right. So let's just use unimultipliers. Let's go 5 hours. So what unimultiplier do we multiply by? That's not the right answer. I don't know what answer that was, but that's not right. Where do you go from hours? Yes,
60
Grady.
minutes over 1 hour.
Yeah, so 60 minutes. And that will cancel the hour. All right. Now, how do you get from minutes to seconds? 60 seconds over a minute. So basically what you're doing, you could just multiply 5 times 3,600, right?
Wait, 60 times 60.
So that will give you, well, let's see, 36. This is going to give you 300, right? What's 300 times 60? Well, 3 times 6 is 18, and then you got 3 zeros. So guess what? 18,000 seconds. That's a lot of seconds. Okay? Now, you could have figured out how many seconds are in an hour. You can do that. Just 60 times 60, right? 3,600 multiplied by 5. But unimultipliers allow you to not have to put so much strain on your brain, okay? Not that this is going to freak you out, but you know, sometimes when you take a test and you can't think straight, that's called test anxiety. Well, you may know how to do this your way here, but when you take a test, you get stressed out and you're dumber. When you take a test, you're dumber. That's science. It's not me being mean to you. When I take a test, I'm dumber. All right? When you take a test, you're dumber. So you have to plan for that dumbness when you take a test. Like, I know you know how to do it when you're stress-free. Like, oh yeah, let's figure out how many seconds are in 5 hours. You know when you do that a lot. Maybe you don't. Okay? But when you're taking a test, plan on your dumbness. You got to take into account your dumbness. All right. One more example, and then I promise I'll be quiet. Should I just be quiet now?
Yeah.
I think I'm done. I think we're good. You guys get it?
Yeah.
All right.